Today, the 2nd of August, 2024, we continue with our course, EDUC 801. And this particular session is for solving problems. From our tutorial questions. So question 5 says, given the data set that we have here, calculate the interquartile range. So we are given these numbers. I will write them through rearrangements. Kindly unmute yourself to make corrections if you notice anything that goes wrong. So rearranging these numbers, I have 3, 5, okay, 7, 8, 3, 5, 7, 8, then 12, and then 13. After that, 14. After that, we have 18, and then 21. So this is what I have. I want to believe I've covered all the numbers. Okay, so now to get our interquartile range like we did in class, we try to locate the middle number, which is the median. Then we know the median of the lower half is the Q1, and the median of the upper half is Q3, and our interquartile range is Q3 minus Q1. So we have this number already arranged, as I've written them out, and then the middle number, 1, 2, 3, 4, 5, 6, 7, 8, 9. So the middle number is going to be the 5th number. All right? The middle number is going to be the 5th number. So this is a dividing line. All right? So now for we to get the Q1 is going to be the median of the lower half. That is the median of these numbers. So the median of this number will definitely be the average of 5 and 7, right? So this is going to be 5 plus 7 divided by 2, which is equal to 6. What about the Q3 is going to be the median of the upper half, and the median of the upper half is going to be will be equals to 14, okay, plus 18 divided by 2. All right? So 14 plus 18 divided by 2. What is 14 plus 18? That is what? 34, right? Okay, sorry, 32. 14 plus 18 gives 32, so this is 32 divided by 2. And 32 divided by 2 is nothing but 16. So Q3 is equal to 16. So our interquartile range, IQR, is a Q3 minus Q1. And this gives 16 minus our Q1 is what? Is 6. So 16 minus 6 is 10. So IQR is equal to 10. Okay? Yeah, the right answer is there, and that is option D. Okay? Perfect. Is it okay by everybody? Good. So to continue, we go to problem number 10. Problem number 10 says, what is the standard deviation of the following data sets? Problem number 10, what is the standard deviation of the following data sets? 3, 6, 9, 12, and 15. All right? Remember, 3, 6, 9, 12, and then 15. The very first thing we do when we want to find the standard deviation is to get the mean of the data sets. So what is the mean? X bar. X bar is 3 plus 6 plus 9 plus 12, then plus 15 divided by 5. Okay? So what is the addition of these numbers? 3 plus 6, that would be 9. 9 plus 9, that is 18. All right? 18 plus 12, 30. Am I correct? And then 30 plus 15, that is 45. So this is 45 divided by 5. And 45 divided by 5 is what? Is 9. So X bar equals to 9. So we have been able to deal with step 1. Step 2 is to make a table, all right, where we have X as the first column of the table. So we list the data sets under X, which are 3, 6, 9, 12, and then 15. We make a line like this. Then we make a second column to be X minus X bar. Please kindly stop me if something is wrong or something is not clear. Then I go back to make explanation before we proceed. Remember, our X bar is 9. So X is 3 in the first data set. So 3 minus 9, that is X minus X bar. This will give us minus 6. Is that correct? Then we have 6 minus 9. 6 minus 9 will be minus 3. 9 minus 9 is 0. 12 minus 9 is 3. 15 minus 9 is 6. This is X minus X bar. Then the next column is X minus X bar squared. Is that correct? So we square the column of X minus X bar. So this will be 36 because minus 6 times minus 6 will give us 36. Minus 3 times minus 3 will give us 9, 0, 9, then again 36. Okay? Since you have got this, we're almost there. Remember our standard deviation, S, so the square root of sum X minus X bar squared over N. I is from 1 to N. And our N, in this case, I'll just still put N. X minus X bar squared. And this will give us 36 plus 9 plus 9 plus 36. What do you get? I got here 36 plus 9 plus 9, then plus again 36. I got here 90. I expect you to also get 90. All right? So this is the square root of 90 divided by N minus 1. N is the number of items in the data set. We have 5, right? Then minus 1 will give us 4. So the square root of 90 divided by 4. So what is 90 divided by 4? Okay. So that gives 22.5. 22.5. So the square root of 22.5 is our standard deviation, which is a 4.74. So S, the standard deviation is 4.74. And the right answer there is what? The right option is option B. Look at it very well. Option A looks like the answer, but it is not. It is just a distractor. Take notes. I want to believe this is also clear to everybody. For that, I proceed to the next question. That is question 15. Feel free to stop me if you have questions or something is not clear. Don't be shy. Just unmute yourself and then interrupt the class. So I go back to make further clarifications. All right, we move to problem number 15. And problem number 15 here says, how does the variance change? Look at this. That is for sure you're gonna have in your test. How does the variance change if each data set value is multiplied by 3? This one you have to think very well. How does the variance change if each data set is multiplied by 3? A, it remains the same. B, it is multiplied by 3. C, it is multiplied by 9. D, it decreases by 3. I think I'm going to open this up. Who is going to attempt this question among you listeners? What do you think will be the right answer? I'm listening to you. What is the answer? Unmute yourself, then make your contribution. What is the answer to this question? Without any calculation.
Good evening, Doc. Yeah.
Yes, good evening.
Okay, I think the answer is option C, 9. How does the variance change if each data set value is multiplied by 3?
Okay, why do you think
so that means how does the variance change if each data set value is multiplied? So if each I think each 3, excuse me, so I'm coming over. This is a bit technical.
Yeah, it's technical, you know.
Excuse me, doctor.
Yes, go ahead, ma'am.
I can't see the question, but I think it will remain the same.
The variance will remain the same. Interesting.
Since each data set is being multiplied by number 3, and 3 is constant in all the data sets.
Yeah. So the variance will remain the same. Okay. Another option, another idea? Another idea? Another idea? Yes, madam, go ahead.
I don't.
Your network is not good. Your network is not good. Another idea from another person? Another idea? Okay, so let us make this let us make it clear now. The right option was actually mentioned by the first speaker, but he wasn't sure about his answer. When each item in a data set, now you can mute yourself to have a decorum. When each item in a data set is multiplied by a constant, okay, the variance of that data set is multiplied by the square of that constant. The variance of that data set is what? Is multiplied by the square of that variance. And that is coming actually from the formula. Variance is S squared, which is equals to sum xi minus x bar squared I from 1 to n. Suppose this is the data set. The data set is what? X1, X2, up to Xn. Now we now have a new data set. This is Xi. A new data set, which is an AXI. Okay? That is, we are multiplying each item in the data set by a constant A. So that is a AX1. Okay, 1 minute. Let me pick my eraser. Or I can even just say this. Okay, that's good. So AX1 plus, back to my pen. Okay, AX1, whoop. This is not good. Okay, good. So we have it to be AX1 plus AX2. Sorry, there's no plus there. Dot AXN. So I'm taking away this plus. Instead, I have what? I have comma. Okay, this is a new data set that is formed from the old one by just multiplying each item in a data set by a constant A. How will the formula look like? The variance of the new one, A squared of AX, will now be equals to, when you are writing this formula, anywhere you see XI, you will replace by AXI. So you have AXI minus X bar squared over N minus 1. This means from this to N, remember, A is a constant. About the mean. The mean, we know that when you multiply the mean by a constant, then each data set in a constant, the mean is going to change. By our previous lesson, we call it transformation. That when you multiply a data set by a constant, the mean of the new data set will be multiplied by that constant. So the mean here is AX bar for this new data set. Okay? So now this A is now common. You can bring it out of that bracket. So you have A into another bracket, Xi minus X bar all squared divided by N minus 1. So this gives from 1 to N. This A now can now come out of that place. A squared into brackets Xi minus X bar squared divided by N minus 1. A is a constant. It has nothing to do with I. A into bigger brackets. Sum I from 1 to N Xi minus X bar squared over N minus 1. So this is A squared multiplied by the variance of what? the variance of the previous one. So the variance of the data set that is multiplied by a constant is actually the square of that constant multiplied by the variance of the original one. This is a generalization. So when you have a data set that is multiplied by 3, okay, then the variance of the new data set is going to be multiplied by 9. So the new variance will now be 9 times x squared. This is extremely important for you to note. Another way through which I can frame this question is, if the data set, look at this question, if the variance of data set x is 7, what is the variance of a data set that is formed by multiplying each item of x what is the variance of then data of another one that multiplied, we got it by multiplying each item in the previous data set by 2, is going to be 2 times, it's going to be what? Term is going to be what? All right, clean it. So variance of 2x will be equals to 2 squared, 4, multiplied by variance of x, which is what? 7. And this is going to be 28. That is it. So without further calculation, this is the kind of question you should expect. If the variance of a data set x is 7, what is the variance of another data set that is got by multiplying each value of the original data set by 2? Another simpler example. If variance of 1, 3, and 5 is 4. Look at this. I like this one. If variance of 1, 3, 5 is what? Is 4. What is the variance of 3, 9, and then 15? What is the variance of what? 3, 9, and 15. Hold on a minute. Look at the first data set, 1, 3, 5. Look at the second data set. Nobody should tell you that the second data set, 3, 9, and 15, is got by multiplying each number in the first data set by 3. 3 times 1, 3. 3 times 3, 9. 3 times 5, 15. So this is the application of this formula. So without any calculation, the factor is 3. Therefore, three, 9, and then 15 is 3 squared multiplied by the variance of the original one, 4, which is what? 36, which is equal to 9 times 4, and that is 36. So the variance of 3, 9, and 15 is what? Is 36. Is it okay, everybody?
No, sir. No, sir.
Is it okay?
No, sir.
No, sir. No, sir.
Okay.
No,
The last example is not okay.
Yes, sir. Yes, sir.
The last example is not okay. Okay.
Yes, sir.
Now, this particular general formula, is it okay by you? This is where I'm coming from. If you have a data set and then you multiply each item of the data set, this is our data set. Then you multiply each item of the data set by a constant A. We have just proved now that the variance of the new data set is equal to A squared multiplied by the variance of the original data set. The variance of the new data set is what? A squared multiplied by the variance of the original data set. We have this example. The variance of this data set X is 7. We now have another data set that is got by multiplying each item of data set X by 2. So we show that by this formula, the variance of 2x is going to be 2 squared, which is 4, multiplied by the variance of the original data set, 7. The same thing, we have this example. This is our data set X now, 135. And we know the variance to be 4. We are now told to find the variance of 3, 9, 15. But I just quickly observed that 3, 9, and 15 is got by multiplying each item of the first data set by 3. 3 times 1, 3. 3 times 3, 9. 3 times 5, 15. So by this formula, the variance of the new data multiplied by the variance of the original one, which is 4. So 3 squared times 4 is 9. 4, and that is 36. Is it okay now?
Yes, sir.
Is it okay?
Yes, sir.
It's very okay, sir.
Excellent.
Thank
So
you,
this
sir.
particular formula is very important. It's very important. Excellent. And then you should know by implication, if it is a standard deviation, it will be multiplied by just that factor. Look, we just proved that given x with variance s, okay, the variance with variance x squared, then the variance of ax, the variance of ax is a squared multiplied by the variance of what? Of s. This is for variance. That is the variance of ax, which I can write as s squared ax equals to a squared multiplied by the variance of x. Now, from here, we can prove that the standard deviation of what? Ax is equals to A times the standard deviation of x. How do we get that? Remember the relationship between standard deviation and variance. Standard deviation is just the square root of variance. So if I take the square root of both sides, standard deviation of ax will now be equal to the square root of a squared is a, standard deviation of x. Wow, what a nice one. So standard deviation of ax is equals to a multiplied by the standard deviation of x. Interesting. So if we quickly go back to this example, the variance of 135 is 4. Nobody should tell you that the standard deviation is 2. Do you agree with me? Is 4. What is standard deviation? If the variance of 135 is 4, if the variance, these are simple things, for example, of 1, sorry, let me take this cleaner in. Okay, 1, 3, 5 is what? Is 4. If the variance of 135 is 4, what is its standard deviation? What is the answer to this? What is standard deviation? Tell me.
It's 2.
Is the
I
square
hope you
root
are not
of
doing the
it's square root
calculation.
of 4.
Eh?
Square
It's
root
2
of
now.
4.
And square root of 4 is what?
It's 2.
Is 2. Thank you. So standard deviation is what? Is 2. Excellent. So is the standard deviation of 3, 9, and 15.
Yes.
Data set that has been got by multiplying 135 by 3. Somebody say what? Eh? What do you say, man?
You cannot recognize.
What is standard deviation of 3, 9, and 15?
It is 3, sir.
It is 3.
Yes.
Is 3 times 2. Standard deviation of the original one. It is coming from here. When you multiply a data set by A, the standard deviation of the new data set equals to A multiplied by the standard deviation of the original data set. So this is original data set 135 with standard deviation 2. And then we multiply the original data set by 3, sorry, to get 3, 9, and 15. Okay, so A is 3. Data set will now be 3 times standard X. Okay, please take note. This is very important. Perfect. So we can proceed with solving more problems. Okay, so let's go to question 20. Question 20 says, which measure of dispersion is least affected by outliers? This one you should tell me without wasting any time. Which measure of dispersion is least affected by outliers? What is the answer? What is the answer and why? Tell us, what is the answer?
Interquartile range.
Interquartile range. Thank you. Why? Why the answer is interquartile range?
Because when we apply interquartile range, we are not using the outliers.
Thank you. We cut off the tail ends.
Yes, sir.
The tail at the beginning and the tail at the end. We cut off the two of them while computing the interquartile range. Unlike the range that we use it end. And unlike the variance, they affect them more than they will affect interquartile range. Thank you. Let's go to question 25. So this one, the answer is the correct option is B. 36. You see what we just proved now, the question has come up. If the standard deviation of a data set is 6. What happens to the standard deviation if each value in the data set is doubled? A, it remains the same. B, it doubles. C, it quadruples. D, it becomes
It doubles. It doubles.
half. Okay. So I just asked you that simple questions and that simple question, and I show you where you find the answer. So tell me, what is the answer to this question number 25? If the standard deviation of a data set is 6, what happens to the standard deviation if each value in a data set is doubled? Please be fast. What is the answer? Does it remain the same? Is it doubled, or is quadruple, or it is half? I hope you understand the question.
I think it remains the same.
You think it remains the same? Can you look at the other side of the question? It doubles. The other side of the question is telling you the answer like this. This is telling you the answer. That if you multiply each value in a data set by a constant, the standard deviation of that new data set is going to be that constant multiplied by the standard deviation of the original. This is very important. Okay? So the standard deviation, in this case now, a data set is multiplied by 2, is doubled, multiplied by 2. So the standard deviation of the new one is going to be multiplied by 2. So its standard deviation is doubled. Question 30. This one, the right option is option B. And then question 30, it says, for the data set 10, 20, 30, 40, 50, determine the range, the variance and standard deviation. Determine the range, the variance and standard deviation. 10, 20, 30, 40, 50. Range is the easiest thing you can do here, which is the highest minus the lowest, which is what? 40. Is it correct? For you to do the standard deviation, you need to get the mean, the variance and standard deviation. You need to get the mean. So what is X bar? Is 10 plus 20 plus 30 plus 40 plus 50 divided by 5. What do you get? That is 150, right? Divided by 5, and that is what? 30. So X bar equals to 30. Are we okay, everybody?
30, yes, sir.
Excellent. So for we to now get the variance, we need to make a table. X, 10, 20, 30, 40, and 50. We make the second column. X minus X bar. Our X bar is 30. 10 minus 30 minus 20. 20. Are we okay? The
Yes,
third
sir.
column, x minus x bar all squared. Perfect. So 100, 0, 100, 400. Is that correct?
Yeah.
Yes. That's 1,000.
Is that
Yes, sir. That's 400 plus 100. That's
from
1,000.
1 to n x minus s squared over n minus 1. So you just add these numbers together, 400 plus 100 plus 100 plus 400.
It's 1,000.
1,000, right?
Yes, sir.
Divided by 4. So this is equals to what?
250.
250, right?
Yes.
250. So x squared, the variance is what? 250. And what is standard deviation? S is equal to the square root of the variance. Okay?
Answer is B.
So what is the square root of 250?
The answer is B.
Eh?
The answer is B.
The answer is B. Okay? So the square root of 250 is what? 15.81.
1.
So you have the range. Yeah. Our range is 40. Our variance is 250. Our standard deviation is 15.81. So the right answer is B. Option B is the correct one. Thank you. Is it okay, everybody?
Yes, sir.
It's very okay. Oh, thank you, sir.
Thank you. Thank you very much. Let's go to question 35. Okay. The daily temperature for a week are 22, 24, 26, 28, 30, 32, 34. What is the standard deviation of this data set? You should do this one on your own. Okay, sorry, I was reading a different one. 35.
Yes,
A survey of household incomes in thousands yields the following data: 35, 40, 45, 50, 55, 60, 65, 70, and 75. Problem number 35. What is simple one? For you to get interquartile range, you arrange the numbers from the to the highest. Thank God this one is arranged for us. 45, 50, 55, 60, 65, 70, 75. Is that correct? Interquartile range will locate the middle, and then we look for the Q1 and Q3. How many numbers we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9. So the middle number is the fifth one. Is it correct? That's the middle number. And then we get, 1, 2, 3, 4. Okay. Let me use different pens like I used before. 1, 2, 3, 4, 5. So this is the middle number, right? Okay.
55.
Then Q1. Thank you. Q1 will be the median of this lower half,
40
which is going to be 40 plus 45 divided by 2, right?
Yes.
95 divided by 85 divided by 2.
No,
and this is
85,
equals to what?
42.
Yep, 42.5. 42.5. This is Q1. And then Q3. Maybe I should use a different pen. Then Q3.
Plus 55.
So that will be the, Q3 will be the median of this upper half, right? And that will be Q3 equals to 65 plus 70 divided by 2. Is that correct? And
No.
this is what? 135.
Yes, sir.
Sir?
Okay, it's okay. I'm following. Sorry.
Thank you. So what is 135 divided by 2? 135 divided by 2, you get what?
67.5.
67. Thank you, ma. 67.5. That is our Q3. So interquartile range IQR, Q1. Our Q3 is 67.5. Our Q1 is
42.5.
-7.5 minus 42.525, right? So the right option there is option B again. There are many B's there. Is it okay, everybody?
Yes, sir.
Yes, sir.
Thank you. So we go to the next problem. That is problem number 40. It says, the monthly expenditure in dollars of a family over 6 months are these. What is the standard deviation of these expenditures? I believe you can do this one on your own. I don't know the answer because I've not done it. But I'm skipping it. So you do it yourself. Let's go
May
to
you see
question
the
number
question?
45. Sir, what do you say?
You know the answer, Oga.
What do you say? I don't,
Carry on, sir.
I don't know the answer because I've
You
not
know
done
the
it.
answer, sir.
Because I'm just doing it. As we are doing it together, I'm just doing it. So you
Okay.
find out.
Okay,
Okay.
sorry, sir.
Problem number 45. It says, if a data set has a small variance, look at this one. It's a conceptual problem. If a data set has a small variance, small one, what can be said about the spread of the data? Please read these options carefully and tell me the answer.
The answer is B.
The answer is
The
B.
data points
A.
are clustered closely around the mean.
Around the mean, okay? Any contrary opinion?
Still go for B. Oh.
Any contrary opinion?
No contrary. It's B.
Sir, it's B.
Is B, yes. Because we
Yes.
said that variance
They are
is a measure
closer.
of the spread of the data. And the
Yes.
smaller the variance, the closer the numbers to the mean.
Yes.
So the right
Yes.
option there is option B. The
It's B.
data points are clustered closely
Closely
around the mean. Okay. So the right option is also option B. Thank you. Yeah. All right. So let's go to question 50. The last question in tutorial and maybe the last question for today too. Which of the following measures affected by, we've already, this is a repeated question. Which of the following measure is least affected by a few extreme values in data set? The right option is what? Is D. This is a repeated question. Okay? In place of that, let us look at question 49. In a data set with a large range, look at this. In a data set with a large range, but a small interquartile range. I'm reading question 49. In a data set with a large range, but a small interquartile range, what can be inferred? Please read these options carefully and tell me what you think.
The answer is B.
The answer is B. The data set has many outliers. Any contrary opinion?
Let him proof now.
Any contrary opinion? The data set has very large range, but small interquartile range.
Because outliers affect the range. The higher the outliers, the more it
The
affects
data set
everybody.
has many outliers.
That's no issue
Don't
on it.
look at that option C.
The middle 50% of data.
What do you see about it? The middle 50% of the data is closely clustered, but there are extreme values. Don't you think this is more correct than B?
Until you help us, because that 50% might bring confusion.
Yeah, you don't need to get any confused. Remember, interquartile range is that 50%.
Okay.
You are saying Q3. You are removing
Okay.
the top 25%.
Okay,
The
okay.
lower 25%. So what is left?
Okay. Yes. Yes. You are, yeah. Well taken answer.
You understand, Ko?
Yes, sir. Very well.
IQR
Yes.
is Q3 minus Q1. Your distribution is like this.
Okay.
You are cutting away Q3. You are cutting away Q1.
Sure.
So what is left in between is 50%.
It's 50%.
Because this is 75%.
25.
You are cutting
that
25
is,
from
yes,
here, 25
exactly.
from here. It is remaining 50. Okay.
Thank you, sir. Very refreshed.
Okay. So
thank you, sir.
yes, I think this is a convenient place for us to stop today.
We are very grateful. Yes, sir.
You're highly welcome. So please
thank you very much, sir.
Your time to go through other questions in the tutorial. I hope you'll be able to solve others by yourself. All right. Okay, and then we see how we can solve the questions together. All right. So any other comments, contributions? The Zanga will not affect that you have chosen, even though after yesterday, I think people are coming down now. So hopefully before next week, Wednesday,